When you are hosting an application in Azure and expecting high traffic, your top priorities become performance, reliability, and scalability. Azure Load Balancer is built to handle this challenge by distributing traffic at the transport layer, which is layer 4 of the OSI model. That means it manages traffic based on IP addresses, port numbers, and protocols like TCP or UDP without worrying about what's inside the packets. Let's walk through how it actually works behind the scenes so you can design with confidence. When you think about how users reach your application, the front-end IP is their entry point, the virtual doorway they use to knock. This IP can be public for internet-facing traffic or private for internal-only traffic within a virtual network. You're not limited to just one. You can assign multiple front-end IPs to a single load balancer, which gives you the flexibility to route different types of traffic to the right services. When a request arrives, the load balancer receives it at the designated front-end IP and figures out exactly how to send it to the right backend resource. That's where load balancing rules come in. These rules act like smart traffic directors, determining how incoming traffic is mapped from a front-end IP and port to a backend pool. They use what's called a 5-tuple hash: source IP, source port, destination IP, destination port, and protocol, TCP or UDP, to evenly and reliably spread out requests. If you want repeat visitors to hit the same VM for session continuity, you can enable session persistence, also known as session affinity. Once traffic is routed, it lands in the backend pool, the real workforce behind your app. This pool consists of VMs or scale set instances that process requests. As you scale your app by adding or removing instances, the load balancer automatically updates itself to include only the healthy ones. No manual intervention needed. But here's the key. Traffic only goes to healthy VMs. Azure Load Balancer constantly checks the health of your backend instances using health probes. You can configure TCP probes to check if a port is open, or HTTP HTTPS probes to make sure your service is responding properly. If a VM doesn't pass the test, it's temporarily taken out of the rotation until it recovers. You set how often the checks happen and how many failures it takes before action is triggered. When it comes to handling user sessions, you have control over how sticky those sessions are. By default, Load Balancer spreads traffic evenly, but you can set it so that a client session always goes to the same backend instance. You can choose no persistence at all, stickiness based on just the client IP 2-tuple, or stickiness based on both client IP and protocol. Now, if you are working with scenarios that involve thousands of ports, like deploying network virtual appliances, Azure simplifies that with high availability HA ports. Instead of creating a rule for every port, you can use a single rule that covers all TCP and UDP flows using protocol equals all and port equals 0. This keeps things streamlined and efficient. Sometimes though, you need a more direct path to a specific VM for tasks like remote desktop or SSH. That's where inbound net rules help. You can map a public-facing port on your load balancer to a private port on a particular VM. For example, port 50,001 on your load balancer could route directly to port 3389 on one specific virtual machine. And finally, outbound rules play a vital role too. These are used to configure source network address translation, which allows your backend VMs to make outbound calls to the internet using the load balancer's front-end IP. It's a secure and centralized way to give your internal workloads controlled access to the outside world. In short, Azure Load Balancer is more than just traffic routing. It's a smart, adaptive system that ensures performance, health, and scalability are always in check. So, what's your key takeaway? Azure Load Balancer gives you a powerful, low latency way to distribute layer 4 traffic across multiple VMs, scale automatically with backend changes, detect and avoid unhealthy instances, customize rules for session stickiness, inbound NAT, and outbound SNAT, handle high volume workloads with HA ports. You've now got the inside view of how Azure Load Balancer works from front door to backend brains. Whether you are building a simple web app or a complex enterprise grade solution, Load Balancer ensures your traffic is intelligently distributed and your app stays available under pressure.